Okay, we are on using rate as a conversion factor. And since rate is a fraction unit, it's considered a derived unit. And we can use that to convert to different units when we have other reactions or other problems related to rates. So if you take a look at the practice problems here, we're going to take a look at the first practice problem where it says ozone is an important component of the atmosphere that protects us from the UV rays of the sun. Certain pollutants encourage the following decomposition of ozone at a rate of 6.5 times 10 to the negative fourth molarity per second. How many molecules of oxygen gas are formed in each liter of atmosphere every day by this process? Okay, so what we want to do is we want to take this rate, 6.5 times 10 to the negative fourth. Molarity is moles per liter. So I'm going to write that as moles of O3 over liter. And that's because you want to emphasize what the substance was that they were given. And then since it's per second, what you can do is 1 over second right next to it. And if we want to convert to liters, molecules per liter, we need to somehow get our moles of O3 to moles of O2, and we can do that by doing a mole ratio using the coefficients. And then we're going to also be converting our seconds into days because they want every day. So let's go ahead and convert the seconds for now. We've got 60 seconds in a minute. So this is gone. And then you can convert your 60 minutes to an hour. And then you can convert your 24 hours to a day. So we've got that done. Since moles of O3 is here, the coefficient in front of O3 is a 2, so you're going to put 2 moles of O3 here. And then we're going to go to 3 moles of O2 here on the top. And then we've got to convert moles of O2 to molecules of O2. So we're going to have 1 mole of O2 has 6.022 times 10 to the 23rd molecules. And then that leaves us with, these will cancel, these will cancel. Here is your molecules of O2 per liter. You're going to end up with 5.1 times 10 to the 25th molecules per liter of O2, okay? Now, for number 2, it says propane gas combusts in camp stoves to produce energy to heat your dinner. How long would it take to produce 6.75 liters of carbon dioxide gas at STP? Assume the gas combusts at a rate of 1.1 C3H8 per minute. Begin by writing a balanced equation for the combustion of C3H8. So this is going to react with oxygen to give you carbon dioxide and water. To balance it, you need a 5 in front of O2, a 3 in front of CO2, and a 4 in front of H2O. You're going to begin with this volume. And since we're at STP, make sure you specify that that's CO2. Go ahead and use 22.4 liters per mole to get to moles of carbon dioxide. The coefficient in front of carbon dioxide is a 3, so it will go here. And then the coefficient in front of C3H8 is a 1, so it will go here. And then you've got to convert to grams of C3H8. The molar mass of that is 44.11. And then we've got 1.10 grams of C3H8 per minute. Okay, so they wanted to know how long it would take. Well, time is going to give you that answer. Multiply everything out, you're going to get 4.03 minutes. For number 3, You're given 2.65 grams of calcium. It's put into water. A single replacement reaction is going to happen. The metal is consumed in 25 seconds. The density of water is a gram per mil. How long is it going to take to consume 5 mils of water? You need a balanced equation, so you have your calcium metal in water. You're going to produce hydrogen gas and calcium hydroxide. Put a 2 in front of water to balance it. You're going to take your 2.65 grams of calcium, and since they want us to solve for time, it would probably be a good idea if we put the time unit number and unit that we're given in the numerator. So I'm going to bring this down a little bit. We're going to put 25 seconds on top, and that's how long it takes to consume 2.65 grams of calcium. So you want to put that on the bottom. Convert your calcium to moles by using the molar mass. So this cancels. And then the coefficient in front of calcium is a 1. The coefficient in front of water is a 2. Then convert your moles of water to grams. And then we can use the density of water, which is a gram per mil. And we can cancel out this milliliters with the 5 milliliters of water that was used. You'll end up getting 52.5 seconds for your answer. Okay, so that's how you can use rate units to convert to others.